Okay, so I'm going to be doing number 15 on the chapter 6 homework. In this problem, Tarzan, who is 85 kilograms, is going to swing on a rope that is 10 meters long across a river. We know that his velocity at the bottom of this path of motion is going to be 8 meters per second. And what we want to do is we want to solve for the maximum tension of this string and see whether or not that's less or greater than 1,000 newtons, which is its breaking point. So essentially what we want to do is we want to solve for maximum tension, and that's going to occur right here at the bottom of the path because the velocity of Tarzan at this point is going to be the greatest. And because velocity is going to be the greatest, the centripetal acceleration is going to be the greatest, which means that the tension is going to be maximized right here. So to do this, remember that centripetal acceleration is not an actual force. It just happens to be the sum of the forces acting perpendicular to the object and the center of motion. So this diagram here shows the forces that are acting on the rope at this point in motion, which are going to be tension and the force of gravity of Tarzan on this point. So basically we can say that the sum of the forces in the y direction equals this diagram. So sum of forces in y equals tension minus mg, force of gravity. We also know that since the centripetal force equals this sum of forces in the y direction, that we can use this equation, centripetal acceleration equals v squared over r, in order to solve for centripetal force. Centripetal force equals mv squared over r, because force equals mass times acceleration. We know that we can solve for this equation and set it equal to this equation, since the centripetal force is just the sum of the forces in the y direction. So we know that mv squared over r equals t minus mg. And using this equation, we can simply plug in mass, velocity, radius, and the acceleration of gravity in order to solve for t. So doing that, mass is 85 kilograms times velocity, which is 8 meters per second squared, over radius, which is this distance 10m, equals tension minus 85 kilograms times g, 9.8 meters per second squared. And just doing the algebra and solving for t right here, we get t equals 1,377 newtons, which is greater than this 1,000 newtons here, which basically means that the rope is going to break and no, Tarzan won't make it across.